Hey, hello, what's up, guys? This is Yasa with another video, and in this video, we'll study about filling of electron in the molecular orbital. Okay, filling of the electron in the molecular orbital. So, our today's topic is this is our today's topic. Okay, but before starting the electron filling in the orbital, let me tell you some of the important things that you have to follow. For filling of electron, there are two things that we have to follow. That is, first, total number of electron. Total number of electron. Okay, means how many electrons does this species have, because we have a different rule for different electronic species. Okay, so let's start with the species having less than 14 electron. For the species having less than 14 or equal to 14 electron, for that the energy order is, for them the energy order of molecular orbital is as follows. So let's start with it. It is sigma 1s, then sigma 2s, sigma anti-bonding 2s, and then pi to px, pi to py, and then sigma to pz. Okay, and this way we have to follow. I'll not go further because this is about only less than or equal to 14 electrons. So we know that the capacity of each orbital is only 2 electrons, whether it is a molecular or atomic orbital. So let me tell you the order of energy. It is in the following way. That is bonding, then it is anti-bonding, so bonding, anti-bonding, this is the order. Okay, and if you see, it is 2 to 4 to 6 to 8 to 10, 12 and 14 I've mentioned over here. So this is the order which we have to follow while filling the electron in molecular orbital. Obviously, I'll be telling you the reason why for the species having more than 14 electron we have to follow a different rule. I'll be giving the reason for that. So here I'll be using the word species because we can write the molecular orbital configuration for ion, or it can be a molecule. Okay, so that's what the word species is being used. Okay, so let's first study the molecular orbital diagram, how to represent it. So let me draw it. So here there will be an vertical line. Towards the left hand side will represent atomic orbital. This side it will be an atomic orbital, and again there will be a vertical line on the right side of which again it will be an atomic orbital, and at the center will be having something called as molecular orbital. Okay, so let's start with the first atomic orbital. Suppose there is the first atomic orbital is this one. which is nothing but 1s, and this also 1s. And we know that these two atomic orbital, that is 1s of one atom and 1s of another atom, will undergo linear combination to form molecular orbital. And in this video we are strictly talking about homoatomic molecule, homoatomic diatomic molecule. Okay, for example, if you're talking about B2, then both the electrons are of boron. So this is the one of the orbital 1s of one atom, and this is of the other atom, and it can be represented in this way. Now these two orbital will undergo combination to form the molecular orbital, and out of those, one will be bonding and other one will be anti-bonding. So the one which is higher in energy is called as bonding anti-bonding molecular orbital, and the one which is in lower energy is called as bonding molecular orbital. So this one is sigma 1s, and this one is sigma asterisk 1s. This one is anti-bonding molecular orbital. Here the asterisk is mainly used for representing anti-bonding molecular orbital. Okay, anti-bonding molecular orbital. So this one is the one, and this is the another one. Now obviously there will be 2s orbital as well, so now it will participate in the linear combination, and obviously again it will form so this is 2s of one atom, and this is again 2s of another atom. It will be forming two molecular orbital. One will be sigma 2s, another one will be anti-bonding 2s. Now the next term is of p orbitals. So we know that in p suborbit there are three orbitals. So this is 1, 2 and 3. This is 2px, 2py and 2pz. In the same way, it will be of another atom, that is again 2px, 2py and 2pz. Okay, so it will also undergo linear combination, and they'll be forming molecular orbital. So you can see here there are two p orbitals. Let me draw. These are the two molecular orbital having energy lesser than the atomic orbital, and then comes to be 2pz. So there is another one. So these are the two atomic orbital with the name pi 2px. So this one is pi 2px, and another one is pi 2py. Okay, so these are the two molecular orbital. This one is pi 2px and pi 2py. We are having another molecular orbital which is slightly lesser in energy compared to atomic orbital. The name of this one is sigma 2pz. It will be like this. Okay, there will be one only, so no need to draw the second one. But there is no need to draw sigma 2pz, because here we are talking strictly about the 14 electronic system, which is being done till pi 2px and pi 2py. So this is all about the filling of electron in the molecular orbital of the species having less than 14 electrons. So now we'll be talking about filling of the electron in the species which are having more than 14 electrons. Okay, so let's talk about them. So this is the order of energy. that is on moving upward, the energy of the molecular orbital keep on increasing. Okay, so this is all about the energy, just make it short. Okay, so this is the energy which keeps on increasing. So let's keep on drawing the molecular diagram. Okay, so here this is our atomic orbital to the respective left and the right hand side, and if you see the level, we are already done with that is 1s and 2s, both bonding and anti-bonding. Now this next one is the turn of the 2p orbital, so let's draw it. So this one is the 2p orbital, and we know that in 2p there are 3 orbital, that is 2px, 2py, 2pz. Okay, and this one is 2px, 2py and 2pz. Okay, so these atomic orbital undergoing combination and they are forming the molecular orbital. The order is somewhat like this. So this one is the one, then here is this one, and then finally comes out with this and this one. So let's first draw it. The purpose of drawing this diagram is very simple, that we want to show you that the bonding molecular orbital are having lesser energy as compared to the orbital which are going under the combination or overlap, whereas the anti-bonding molecular orbital are having higher energy. So let's draw it. So this one is nothing but sigma 2pz. Okay, and these two are pi 2px and pi 2py. This one is again 2 anti-bonding, that is pi asterisk 2px and pi asterisk 2py. And finally comes the highest energy orbital, that is nothing but sigma 2pz. Okay, so this is all about the filling of the electron in the molecular orbital. Now just by writing the electronic configuration, you keep on filling the electron in the molecular orbital. So I hope you understood the video thoroughly. Okay, do share it with your friends so that they'll get good understanding of molecular orbital. Please press the bell icon so that whenever I'm making a video, you'll get the notification. Okay, thanks a lot for watching. Have a nice day.